previous lesson, we know that the soil fertility is the ability of soil to sustain plant growth by providing those essential nutrients. Meron tayong those 17 essential nutrients, macronutrients, micronutrients, all of those nutrients that plants needed. And the word soil fertility management refers to the practices and strategies used to maintain and improve soil fertility and to enhance soil productivity. So yun yung mga terms na na-discuss previous topics. So, modern soil fertility management, ito yung i-discuss natin ngayon. And this refers to the application of advanced technology, specific knowledge, and innovative practices to optimize soil fertility in a sustainable manner. Atin malalaman kung paano natin mamamanage yung fertility ng soil for it to sustain good growth and provides nutrients to plant in a modern way. So this topic will be covers the aspects of modern soil fertility management. We have 7 aspects of modern soil fertility management or MFSM. We have soil testing and analysis, nutrient management, organic farming practices, conservation tillage, soil amendments, precision agriculture technologies, integrated soil fertility management. To start, we have first the soil testing and analysis. Note the first aspect, soil testing and analysis. This aspect is to assess nutrient levels, pH balance, and soil structure. In soil test result, dun makikita kung anong recommendation of correct fertilizer, kung gaano karami ang fertilizer and organic matter that should be applied to secure the right dosage of fertilizer, and most of all, para hindi masira yung soil. So, dapat malaman mo kung ano ang lack of nutrient in that soil para maka-create ka ng recommendation kung anong correct fertilizer yung i-a-apply mo. And also, to get or secure the right dosage, right amount of fertilizer para hindi ma-toxic yung soil, yung characteristic ng soil. There are 2 ways to get soil sample. First, we have random sampling. Dito, kukuha ka ng sample in different places in your farm. So, within your farm, kukuha ka dyan ng sample, mga 15 to 20 samples, pwede na yun. And you cannot mix that soil sample na nakuha mo in that particular area to the other area na sample na nakuha mo kasi magkaiba yung soil structure nila and yung soil properties nila. The second one, we have zigzag sampling. So, it follows the zigzag pattern, of course. So, from the starting point to the end point, dun ka lang kukuha ng soil sample mo. In collecting soil sample, hahatiin yung magkakapareho na slope, texture, lalim ng soil, and drainage, and also what should we plant. There's 2 ways of getting soil sample. Dito mo kasi malalaman kung in that particular area kung ano ang dapat nating itanim dyan. And also malalaman natin kung ano yung properties and characteristics ng soil na nandyan sa lupa na yan. Essential nutrients of nutrient management. Actually, we have 17 essential nutrients, but we get only the macronutrients and the trace elements, or also what we call the minor or micro elements. The macronutrients, we have the NPK. nitrogen, phosphorus, and potassium. Also, we have the air and water, the CHO, carbon dioxide, hydrogen, and oxygen supplied by air and water. We have also the secondary nutrients like calcium, magnesium, sulfur, and also the trace elements, the boron, zinc, iron, manganese, copper, chlorine, molybdenum. Mass flow, a term that refers to a movement of nutrients in soil through the flow of water. The process plays a crucial role in the uptake of essential nutrients by plants. When plants absorb water from the soil through the roots, they also takes up nutrients dissolved in the soil water. These nutrients such as nitrogen, phosphorus, and potassium, and other minerals are essential for growth development of plant. As the water flows through the soil, it brings nutrients in solution closer to the plant roots, facilitating their uptake by the plants. Importance of cation exchange capacity as follows. Nutrient retention, ability of soil to hold onto essential nutrients and prevents them from being lost through leaching or runoff. Secondly, we have nutrient availability. Those essential nutrients required by plants present in a form that can be taken up by plant roots for plant growth. The third one, act as a buffer. So CEC acts as a buffer. How certain components such as organic matter, soil pH can help maintain a stable environment by regulating nutrient availability, then controls levels of waste disposal, and lastly controls levels of herbicides.
Hello everyone, good day. I am Jessie Grace Abelasio and I will going to discuss the organic farming practices and conservation tillage.
What makes a farm organic? Organic farming works in harmony with nature since organic farmers don't use synthetic fertilizers, GMOs, or pesticides. They have to fight insects, diseases, and weeds and grow abundant food with the help of other methods. What connects all organic farming practices and their ultimate goal? To build and improve the soil, quite literally the foundation of our food system and our lives. What is healthy soil? Healthy soil is what which allows plants to grow to their maximum productivity without disease or pest and without a need for off-farm supplements. Healthy soil is teeming with bacteria, fungi, algae, protozoa, nematodes, and other tiny creatures. Those organisms play an important role in plant health. Soil bacteria produce natural antibiotics that help plants resist disease. Fungi assist plants in absorbing water and nutrients. Together, these bacteria and fungi are known as organic matter. The more organic matter in a sample of soil, the healthier the soil is. What are cover crops? Cover crops' primary job is to improve the soil. They get planted in fields that would otherwise be bare. In between growing seasons, for example, to protect the soil from erosion and nutrient loss. Cover crops are different from cash crops, which are those that our farmer sells for profit, such as corn or soybeans. Cover crops also help water weeds, control pests and diseases, enhance water availability, and increase biodiversity on the farm. Think of cover crops as a living mulch. What is crop rotation? Crop rotation is the practice of planting different crops sequentially on the same plot of land to improve soil health, optimize nutrients in the soil, and combat pests and weed pressure. For example, a farmer has planted a field of corn. When the corn harvest is finished, he might plant beans since corn consumes a lot of nitrogen and beans return nitrogen to the soil. A simple rotation might involve 2 or 3 crops, and complex rotations might incorporate a dozen or more. What is compost? Compost is created from the aerobic decomposition of many materials usually considered waste, including food scraps, animals, manures, leaves, straw, and more. Composting occurs when carbon-rich materials browns, like straw and leaves, are mixed with nitrogen-rich materials greens, like food scraps and manure. And oxygen, time, some field management, and the help of billions of microorganisms, the finished result is crumbly, sweet-smelling, and nutrient-packed compost. What is tillage? Tillage is the practice of digging up, turning over, or otherwise agitating the soil with mechanical tools, typically a plow or disc. Tilling breaks up soil compaction, helps eliminate weeds, and incorporates cover crops for boosted soil fertility. These are important benefits, but tillage also leaves soil vulnerable to erosion and destroys important fungal networks underground. Tillage is also soil and labor intensive. Some farmers, both conventional and organic, practice reduce tillage or try to eliminate it altogether. What is organic pest management? Organic pest management may include the use of pheromone traps, release of beneficial insects, use trap crops, and other organically approved techniques. Bugs and insects are given on any farm. Some bugs are beneficial, they prey on the bad bugs and provide valuable pollination, but other insects pose a threat. Pests can damage the appearance of fruits and vegetables, making those products difficult or impossible to sell. Even worse, some pest damage can kill a crop outright. Conventional farmers spray toxic pesticides to eliminate pests. Organic farmers use alternative strategies to reduce and control pests without the use of synthetic inputs. Organic livestock management. Organic livestock are managed differently than conventional livestock, with an emphasis on pasture and restrictions on the use of antibiotics and hormones. Organic livestock benefit people and environment. Animals raised organically have a better quality of life than their conventional counterparts too. What is rational grazing? Rational grazing is the practice of containing and moving animals through pasture to improve soil, plant, and animal health. Only one portion of pasture is grazed at a time, while the remainder of the pasture raised. To accomplish this, pastures are subdivided into smaller areas, referred to as paddocks, and livestock are moved from one paddock to another. What is conservation tillage? Conservation tillage cultivates land that uses leftovers from last year's crops to reduce soil erosion and runoff. This can be stalks of corn or any other crops. Farmers use them to cover fields before and after planting a new crop. At the same time, organic residues on the ground surface account for at least 30% of planted area's entire surface. Conservation tillage has advantages and disadvantages. It has a lot of advantages, among which the following can be discussed. First is increases the soil's ability to store carbon. It also improves the resistance of the ground top layer to the emission of harmful particles in the air and wind erosion. It also facilitates the moisture penetration into the soil, reduces the leaching of nutrients due to the preservation of a large amount of organic matter, lowers the moisture evaporation from the ground, which saves the harvest in dry years. It also helps to retain pesticides and other valuable chemicals in the soil, requires less land cultivation. There is also a specific negative impact on the environment. Consider some drawbacks. It can The conservation tillage requires expensive equipment or a lot of manual labor if we are talking about small producers. Then, unlike traditional methods of weed and pest control, it demands more pesticides and herbicides. The first positive results of conservation tillage are visible only in long run. The method contributes the greenhouse gases emissions CH4 and N2O. There are 5 types of conversion tillage. First is no-till, zero-till. Second is strip tillage. Third is range till. Fourth is mulch till. Then the fifth one is reduce or minimum tillage. No-till or zero-till. Among all the methods of conservation tillage, this one minimally disrupts the topsoil through single-pass seeding and fertilization. Farmers make only shallow seed beds and cover them with mulch from plant residues. Accordingly, the fertilizer quality is of prime importance for conserving soil and water. This type of conservation tillage, in particular, is used in northern Tanzania for the processing of wheat and coffee plantations. Then the next one is strip tillage. This type is also known as zonal tillage. The principles is to divide the field into 2 parts, seedling and soil management. The first is processed mechanically to optimize the ground and microclimate. You shouldn't process the second one, just treat it with cover crops for conservation tillage systems. Additionally, rows can be made for better water penetration. Then, ridge till. So this kind of conservation tillage planting is characterized by creating beds with a special equipment's help. This process is called scalping. It is suitable for spring crops, which is why it is gaining popularity in the United States to conserve soybeans and corn. The major problem with conservation tillage is the high cost of technology. Cultivators used for loosening should be heavy and sturdy enough and cost more than $1,500 per row. However, you can rent the equipment if companies in your area provide such a service. Then, we have mulch till. Mulching covers the ground with a layer of residues which are cultivated with cultivator sweeps and chisels to mix with the soil partially. In this case, the mulch should cover 1/3 of the surface at least. The conservation tillage method was developed in the 1930s to combat with erosion. Such a practice is suitable for large and small farmers alike when growing both annual and perennial crops. Then, the reduce or minimum tillage. These methods of conservation tillage is inherently similar to no tillage and may differ from region to region. It aims to minimize damage to the topsoil. It includes the use of biological insecticides and fertilizers, mild chemicals, and reduced furrowing.
Good day everyone, I am Sherry P. Antigon. Today I will discuss soil amendments and precision agricultural technology. So what is soil amendments? Soil amendments are materials that are added to soil to improve its physical and chemical properties, making it more conducive to plant growth. It is also can be organic or inorganic and can include a variety of materials such as compost, manure, lime, gypsum, and vermiculite, among others. Here's our more detailed look at soil amendments and how they can be used to improve soil health. So the first one is organic amendments. Organic amendments is derived from living organisms such as plants, animals, and microorganisms. Examples of organic amendments include compost, manure, peat moss, and leaf mold. And the second one is inorganic amendments. It is derived from non-living materials such as minerals and rocks. Examples of inorganic amendments include lime, gypsum, vermiculite, and perlite. Then next is pH adjustment. Lime is common inorganic amendment that is used to adjust soil pH. Then sulfur can be added to soil that is too alkaline or high pH to lower pH level and make the soil more acidic. Then the next one is nutrient content. Nutrient content in soil amendments, it can also be used to add nutrients to the soil. Then soil structure. Soil amendments can improve soil structure by improving water retention and drainage. Then next is application. In soil amendments, it should be applied based on soil test results and the specific needs of your soil. So in summary, soil amendments can improve soil health by adding nutrients, adjusting pH levels, improving soil structure, and increasing water retention and drainage. And it is important to select the right amendments for your soil and to apply them correctly. Precision agricultural technologies. Precision agriculture uses technologies such as GPS or automation to make farms more efficient. For example, farmers can use auto-steering equipment to precisely plant a field, and activity monitors can help dairy farmers collect data about their cows' health. And the examples of technologies used in agriculture is also known as our agri-tech. Encompasses a broad range of disciplines and devices that improve agricultural output. That includes vehicles, robotics, computers, satellites, drones, mobile devices, and software.
Integrated soil fertility management. Integrated soil fertility management is an approach that aims to sustainably increase agricultural productivity by optimizing soil fertility through the integrated use of organic and inorganic nutrient sources. Integrated soil fertility management is an agricultural approach designed to enhance agricultural productivity sustainably by optimizing soil fertility through the integrated use of both organic and inorganic nutrient sources. This approach aims to maximize crop yields while minimizing negative environmental impact. So, here are key components of integrated soil fertility management that contribute to its effectiveness in improving soil fertility and increasing agricultural productivity. 1. Balanced nutrients management. This emphasizes the importance of providing crops with a balanced supply of essential nutrients, combining organic sources such as compost, manure, and crop residues with inorganic fertilizers. Number 2. Soil health improvement. Integrated soil fertility management focuses on improving soil health by enhancing soil structure, increasing soil organic matter content, and promoting beneficial soil microorganisms. These improvements contribute to better nutrient availability, water retention, and overall soil fertility, leading to increased crop yields. Number 3. Nutrient cycling. Integrated soil fertility management promotes efficient nutrient cycling within the agroecosystem by incorporating practices like crop rotation, intercropping, and agroforestry. Integrated soil fertility management helps to recycle nutrients, reduce nutrients losses, and improve nutrients use efficiency. Integrated soil fertility management is a comprehensive approach that addresses key aspects of soil health and fertility to increase crop yields sustainably. By prioritizing soil nutrients availability, beneficial soil organisms, erosion control, and overall soil health, Integrated soil fertility management help farmers optimize agricultural productivity while preserving the environment and ensuring the long-term sustainability of farming system.